Hello, welcome to our AB Mev Education YouTube channel. Please, today is your first time or you have not subscribed, go ahead and subscribe so that you can see all the videos that I have in store for you. Today we are going to look at how we can able to apply the surface area and the lateral surface area to make a decision. Okay, so our first question here, we have been given two boxes here, and as a student or as a manager working in a canning factory that produces packages for a brand of cereal, we want you to decide which one that they should choose, and you have to give them the reason. They have given you the condition that you have to meet, which is they don't want more than 9 centimeter tall, and they want the greatest lateral surface area as possible so that they can print the nutrition information and some designs on it. So here, this is example of a package that they want. They are not interested with the top and the bottom. They are interested with the lateral. And they want a bigger one and with a specific height. So as we are calculating, number one, so as we are looking at the B, this is the lateral area. There is a 4 section of it. This is one of it. There is one behind. There's also one behind, and another one beside here. Comes a bit down here, and then the last one, the one here. Okay, so there's 4 sections of it. So we want to calculate, and that shape, the rectangular. So one of the rectangular, which of 4 and 9, in the area of this. So we are looking at the A1 is just the area is just 9 times 4, and that gives us 36. 4 sections of it as we see. So you multiply by 4, and that gives us 144. And this is the lateral. That's the lateral area of the box A. Yeah, so centimeter, so it's going to be centimeter squared. All right, when we come to the box B, that one of the rectangular area is 5 and 9. So therefore the area, which is 2 dimension, is going to be 9 times 5. That gives you 45. But it's of 4 sections, so you multiply by 4, and that will give us 180 centimeters squared. And this is the lateral area of this box B. That gave you that. So based upon the information that they gave us, they want a bigger surface area so that they can print the nutrition information. So with all the indications, since this 180 is bigger than 144, we will recommend box B for them to use it for this production. So here, the same company, this time around, they are trying to produce a can, which is of cylinder. They want the height no more than 9 inches, but they also want to maximize the material. They don't want to use much material. So because of that, we have to look at the total surface area. So here, this question calls for surface area. And we know that it's a can. So because of that, it's going to be a cylinder. Surface area of a cylinder is 2 pi r squared, which is the top and the bottom, plus the lateral, which is 2 pi r h. So that's the formula. And as we are doing the calculation, I will recommend that we simplify the surface area. Most of my students like it this way as 2 pi r, and then one more r here, which is the radius, plus here the height. Normally this helps them to work so quick. So when we come to the can A, 2, so here we are going to take pi to be 3.14. We take 2 times pi, which is 3.14, times the radius, which is 4 here, and then times the radius plus the height, which 4 plus 6, which we get 2 times 3.14 times 4 times 10, and you're going to get 251.2 inches squared. We come to can B, 2 times 3.14 times the radius, which is 3, times you add the radius to the height, and that will be 11, and then you multiply it, you're going to get 207.24 inch squared. Then we come to and see, so the formula got 2, so 2 times 3.14 times the radius is 2 times radius plus the height, which is 14, and then you get 175.84 inches squared. Okay, so here we have able to calculate all the surface areas. So now it's time for us to make a decision. So we realize that I can see, okay, so here we have calculated all the surface area. So realize that the can A will need a lot of materials because the surface area is really huge, followed by the B and then by the C. So C is the smallest material that we need in order for us to make it. We have to look at the next requirement, which is 9 inches. This is the height is 12, so we have to reject that one and then go for a can B. So we will recommend can B. So this is the one that we will recommend for them to use it. Right, so we have this shape here, and there is a shaded part of it, which is all this section here is shaded, and that's the roofing that we need to roof it with the shingles. The shingles measure 2 by 2. First of all, we need to find the area of the shingles. So the area of the shingle is 2 by 2. So 2 times 2, which is 4. So it's 4 feet squared. Then we need to find our total area of the roof. So the roof, the shape is looking like this, which is a rectangle. You need to find the area of a rectangle. So area of a rectangle is length times width. So here the length is going to be the same as the 22. So here it's going to be 22. So we're going to get 22 times 5 is going to be 110 feet squared by of 2 sections. So for us to find the total area of the roof, it's going to be 2 times 110. It's going to be 220 feet squared. And therefore, for the number of the shingles, the exact shingles needed is going to be the total of the area that we needed divided by the size of the shingle, which is 4, and that have to give us 55. So we need exactly 55 shingles to roof this roof. Here they were looking for exact, so we didn't actually estimate it, a little over in case some of them is going to mess up. Here they needed exact, so the exact is going to be 55. But as your own building, then you have to buy more than that because some of them might mess up along the line and you need a replacement. Thank you for watching. Please, if you haven't subscribed, please subscribe so that you can see all the videos that are in store for you. I say bye bye.